Hello, everyone. Thank you for attending my presentation at the JCon online conference. The topic of my presentation today is serverless on Knative with Quarkus in Kafka. If you have any questions, also ask them during the session. Maybe we'll have some time after the session for asking questions, but we have some prepared for the whole time. Okay, so before we start, some words about me. My name is Piotr Mińkowski. Currently, I'm working as a solution architect at Red Hat. Privately, I'm interested in Java, Kubernetes, and cloud native development for years. I'm writing about it on my blog, Piotr Mińkowski.com. Okay. So today we'll talk about very promising technologies like Knative, Quarkus, and Kafka. We will run all of these technologies on OpenShift. So here's the plan of our presentation. It's very simple. So we'll start with a short theoretical introduction. I'll tell you some words about the idea behind Knative and serverless on Kubernetes. I try to give you a brief intro into the Knative features and components. After that, we will proceed to the Knative framework. For those who hadn't already heard about it, I make a short introduction also, and then we'll talk a little bit more about serverless and Knative specific features. Finally, we will run a simple demo applications written in Quarkus on Knative. They will use also Knative eventing components for publishing and consuming events. Okay, so let's begin with two definitions. I really like this explanation of serverless pattern because it illustrates very well the idea behind Knative. So serverless is a deployment model that allows us to build and run applications without requiring a deep insight into the underlying infrastructure. Of course, we are not thinking just about the physical infrastructure. In our case, it is rather related to the Kubernetes platform, and it does not require, for example, us as developers that we have to understand Kubernetes to configure some more advanced networking or auto-scaling scenarios for our applications. Okay, so next definition, Knative is the last definition in this presentation, I promise. So Knative is a Kubernetes-based platform to build, deploy, and manage modern serverless workloads. And what is important for us, it's also a developer-friendly software. So it's designed to hide the complexity, as I mentioned before, of a Kubernetes platforms against developers and takes care of such mechanisms like auto-scaling, which is not very easy on Kubernetes, especially for some different parameters, networking, or for example, revision tracking, so switching between previous versions of application. And thanks to that, you can just focus, of course, on your core logic. And also, Knative, of course, does not do any magic. It just recognizes images as deployment units. So under the hood, you've got deployment pods, of course. But of course, you can use any language framework or idiom you are familiar with. And what is important, you can run any type of application on Knative, not just a function. Yeah? But of course, it is designed for small applications that fast start fast, and do not consume much memory. Okay, so currently, Knative may be divided into two different components, serving and eventing. Both of them provide a set of CRD. So for Knative serving, these objects are used to define and control how applications running on Knative and how they behave on the cluster. And Knative serving takes care of details like networking, auto-scaling, revision tracking. Okay, so I have mentioned about it. And for Knative eventing, the objects control how these events are exchanged between Knative services. Okay, so it provides also an universal model for subscription, delivery, and management of events in your, for example, event-based, event-driven architecture. And thanks to that, you may build a modern application architecture using declarative event connectivity, and you've got everything in the YAML manifest. This diagram illustrates the architecture of Knative Serving component. So there are 4 objects used for configuring behavior of applications running on Knative. The most important is, of course, a service object. It automatically managed the whole life cycle of your workload on Knative. It also controls the process of creating objects like route, configuration, or a new revision for each update of our service. So you can create a service object using YAML manifest. You can also do it using a command line, natively. And each time you update your existing service, you are creating, in fact, a new revision of that service, which is a target of incoming traffic, okay, which may be a target of incoming traffic. So you can easily split this traffic between multiple revisions using a percentage-based request distribution. So, of course, you can just send the whole traffic to the latest revision, and in fact, it's default behavior. To expose your service outside Kubernetes cluster, you will use a route object. It provides HTTP request routing between multiple revisions, in fact. Configuration resource maintains a state of your deployment. It provides some kind of separation between code and configuration. So each time a configuration is in fact modified, a new revision is created. Okay, so this revision is just a snapshot of the code and configuration for each modification of Knative service in this way. And of course, revisions may be retained as long and as you use them, because you can just, for example, use the latest revision, and you can remove all other revisions because you don't need them. Okay, so you can, of course, scale up and scale down these revisions according to incoming traffic. And what is important here, you should not modify any object except Knative service. Yeah, because if you modify Knative service, all other objects are automatically updated. Okay, so if Knative eventing component, you can link event-driven architecture or Knative, for example. So Knative uses also a HTTP post request to send events between producers called sources and consumers called sinks. So this the messages exchanged between application follow the cloud event specifications. A specification, I'm not sure if you're familiar with, but it's a simple specification. Of course, it's a part of CNCF framework. It adds some headers to the messages, and of course, it provides a standardized way and protocol-agnostic way of describing events in event-driven systems. There are, in fact, multiple supported event source types, including, for example, Apache Camel, Kafka, RabbitMQ, or AWS SQS. And of course, there are some very basic sources just for testing, for example, like a ping source that periodically sends events with a constant payload. The same as in Knative Serving, there is also a set of CRD objectives to control the process of sending and receiving messages. You can propagate events sent by sources using, in fact, 2 approaches. It's quite confusing something. So sometimes the first of them is based on channel and subscriptions, while the second is based on broker and triggers. And in this session, I'm going to show the second approach, which is based on the event broker. Broker in this approach is just responsible for collecting a pool of events. You can send the events to the broker just by posting them to the exposed endpoint. And even deliver mechanics depends also on the configured broker class, because there are multiple broker classes available. And we'll use a default broker. It's a multi-tenant multi-tenant channel-based broker implementation that uses channels for event routing. But you can also use some alternative implementations, like, for example, Kafka, RabbitMQ, or GCP broker. But we're, of course, saying about Knative broker. Okay, so once the event is delivered to the broker, it can be forwarded to the multiple subscribers using an object called trigger. Trigger may filter events based on their attributes. So for cloud events, we may use their HTTP headers for filtering. And thanks to triggers, we may deliver events just to the subscribers that are in fact interesting in this type of event. Okay, so let's proceed to another topic, Quarkus, a framework we'll use in our demo session for building applications. Quarkus is built on top of microprofile and vertex framework. It's a Kubernetes native framework. What does it mean? Okay, for example, if you compare it to another frameworks, it does not provide any built-in integration for external discovery servers, right? So, but instead it offers several simplifications that speed up your development on Kubernetes, OpenShift, and what is important for us today, Knative. What are those simplifications? We'll discuss them in the next slide and of course during the demo session. But Quarkus, what is important, is tailored for running with GraalVM native images, and it is optimized for low memory footprint and fast startup time. So those are typical characteristics required by microservices and even more by serverless applications. Yeah. Well, Quarkus provides several extensions and for building container images, for example, with Git. And if you deploy it on OpenShift, it supports source-to-image mechanisms, so building image container directly from the code. For both these tools, it offers a dedicated base image base to be used. Okay, so Quarkus also offers the ability to automatically generate Kubernetes resources based on the source code, user configuration, application properties, and of course annotations, because it uses decorate library under the hood, but it's not very important here. However, it currently supports generating resources for vanilla Kubernetes, OpenShift, and of course Knative. And Quarkus can also deploy application to a target Kubernetes cluster just by applying these manifests generated during the build to the target cluster API server. By design, also expose health checks dedicated to liveness and readiness probes, typically set for deployments on Kubernetes. And finally, it provides a function module we'll use also in the demo session with functions implementations for serverless. Thanks to that, we can easily integrate our Quarkus application even with the Knative Eventing model to take some more advanced routing and processing Knative events with a function module. Okay, so let's take a look at the diagram that illustrates our scenario in the demo session. We have three applications. In fact, we have an application that generates events and sends them to the Kafka topic. It's called order service. It's responsible for generating some kind of orders that are handled by two other applications, payment service and stock service. We need to use Kafka source CRD object to get messages sent by these applications and to forward them to a Knative broker. Okay, so events that are delivered to the broker are forwarded to subscribers using our object triggers. Okay, so we have two applications that consumes events and two triggers that are responsible for filtering these events and sending forward to these applications. And I'm going to show you a very trivial implementation of SAGA pattern. It's also called an eventual consistency. It's often used in microservices architecture to manage distributed transactions across microservices. We have a simple implementation. In our scenario, we'll send orders related to the customer that contains products. This customer just want to buy. Okay, so if a customer has a sufficient funds on the account and there are enough products in the stock, the order is confirmed. Otherwise, it is rejected, and our reservation should be rolled back. So in fact, we are implementing SAGA pattern. Okay, so that's our starting point. I'm using OpenShift to deploy all these applications. The Kafka broker is already deployed in the Kafka namespace. I have already created a Knative broker. So these are our components. Let's just switch to the code. I can show you, for example, that a broker is already created. Okay, we've got a broker, it is ready. We can, for example, list services in Kafka namespace because we have our Kafka cluster installed different messages that we are working on. Okay, so you can wait for this. Okay, so we'll use this service for connecting Kafka. I have already deployed a single service on Knative here, so we can also list the services using Knative tree. You see that it is ready and is valid. So we can back for a moment to this presentation. Okay, so here is it. All right, so we'll start with a simple implementation. First, we've got Quarkus application. We use Maven for building this application. I will just switch to the Maven XML. I add two dependencies now. So first is responsible for integration between Quarkus and Kafka. Okay. Second is a Quarkus Funqy HTTP module. It is responsible for providing functional programming features for applications. So in just we need to add it. Okay, so that's what we need to do on the beginning. And now let's first of all, we are switching to the implementation of our function. And we need to annotate this method with a func annotation. So it tells Quarkus that it is implementation for a function. And also Quarkus HTTP, Funqy HTTP will bind this function as HTTP endpoint with the context part the same as the name of this service. Okay, and that's all what we need to do to expose this endpoint. Now we can switch to implementation. We've got, in fact, two scenarios here. So the first scenario is when we receive a new order from order service. It means that it has been just generated and sent to the service. So it has a status of new. Okay. So if we receive a new event, we are performing just a reservation. So we are reserving, for example, in this case, an amount of the customer on the customer balance. Okay, so we are just sending it to the doReserve method, and otherwise we are received some kind of confirmation. So this scenario where payment and stock service, those two subscribers, has sent a response back to the order service after receiving a new order, and now order service has sent a message if we should confirm the transaction or roll back the transaction. Following that, what I said before. So, for example, if there is no sufficient funds in the accounts, payment service will reject this order, and it has to be also rolled back on the stock service side. Okay, so now we can switch to the doReserve implementation. First of all, we need to check if there are sufficient accounts on the customer in the customer balance. So we are just getting value for the order. Order get amount needs to be lower than or equal to the customer balance. Okay, so that's the first case. So otherwise, we need to reject this order. Okay, so we are just setting the status order rejected. Okay, in other way, we can just set it to the in progress. So it means that we are accepting it and we are waiting for confirmation from the order service. Of course, we need to provide some implementation here. So first of all, we need to withdraw this amount declared in the order from the customer account. So we are just okay. So get amount reserved. We need to add it here. Get amount. And here we are setting an available amount. So we are getting a current value and removing this from this field. So we are just transferring this funds to the temporary field like amount reserve. Okay, and of course we need to save the state of our objects. So repository persist. Okay. So it's all. And also, after handling this event, we need to send the response back to the order service. Okay, so we will use another topic for that than the input topic. But first of all, we need to use a sender send order. Okay, and in Quarkus, we are using emitter object for sending messages to the Kafka broker on demand. So we just need to declare this emitter, inject it here, and we also have to define a channel, output channel for this object. It is some kind of high-level implementation, but in fact we will use the same topic name as the name of the channel. But let's just add it here. Sorry, order sender once again. So reserve events. Okay, and now we just need to send this order using emitter order. Okay. Okay, so we have already finished the implementation of the reserve method. Now we can go to the confirmation method. So we can receive a confirmation or rollback. So we just need to analyze the status. So if the status of order is confirmed, we need to confirm it, or otherwise we need to roll back the transaction. So order get status status is in this way order. We also need to compare if if our service has rejected this order. So if it has not rejected the order, we should perform a rollback. Okay. So that's all here. And okay, so if we are performing rollback, we are just doing an opposite operation here to the previously performed operation. So we need to add this amount into the amount reserved and remove it from the reserved field. Okay, so if order has been accepted, we just don't have to do anything on the amount available field, because we just need to remove this reservation. It has already been created here on the amount available field. And of course, we need to persist the state of this object. We can add some logs like order confirmed, and print this order. We can also add another log. Order has been rollback. Okay, So that's the whole implementation in this service. And now we need to switch to application properties, because as I mentioned before, we just need to configure our service now. First of all, we need to configure connection to Kafka. We'll just use it to send some messages, we'll not directly subscribe for the events from Kafka topics. It will be performed by Knative Eventing. So we just need to define the name of our topic, and it is the same as the name of the channel, just for simplification. Okay, so it is reserve events. We are using a default object serializer. We are using a SmallRye implementation of Kafka connector. And here we are setting environment variable for Kafka address. So currently, as you see, our application does not know anything about the address of Kafka cluster. Okay, so in the next step, we need to deploy it on OpenShift. So now I will use another Quarkus model just for integration with OpenShift. Quarkus OpenShift model, okay. And I just need to inject here, and I need to add some configuration properties to the file. So there's a Quarkus Kubernetes deploy. And so if I set it to true, it means that during the build, during the Maven build, Quarkus will try to connect with my existing OpenShift cluster and try to deploy our application on this cluster. Okay, so we can also we need to change the deployment target, because by default, Quarkus tries to deploy on Kubernetes. Here we want, of course, deploy to OpenShift, but also Knative. So we want to create a Knative application, not just a simple application that is running on Kubernetes. And the last thing, we need to set it, because we will use an OpenShift source to image mechanism for building our images. So we need to set the address of registry. And this address is an internal address of OpenShift cluster. So it's an OpenShift image registry, and we can just copy it, paste. But we can also easily check it, for example, using OCGet in the OpenShift. So you see that you'll see that the internal address of our registry is the same as address I have already inserted here. Okay, so that's what we did. Okay, so now we just need to deploy our application to the OpenShift. Maybe we need to run, for example, Maven clean package. So as I said, because we set this property during the build, it tries to automatically deploy our application on OpenShift. So you see it's my instance of OpenShift cluster. And the last thing in this configuration is important, this environment variable. As I said before, we don't have to know anything about the address of Kafka cluster. We just need to inject it. We can just inject it using a declarative way with a CRD object called Kafka binding. So let's just list once again services exposed by the Kafka. We'll use the Kafka Bootstrap server. Okay, so we can just place it here. We'll use a plain port for that. It is in Kafka namespace. So we are setting it here in the Bootstrap server fees. Of course, we can also use Kafka binding for injecting, for example, credentials to Kafka or something like that. But here we've got a very simple scenario where we just use a plain port without any authentication. Okay, so you see our application has been deployed, but what I show you now, it won't work because we didn't inject. We didn't inject. Okay, you see, maybe we'll just be able to easily see these logs here. Okay, let's take a look. Okay, you see there is no this environment variable set. Okay, so we just need to set it as I mentioned before. So I have already defined this object. So let's apply the configuration. It is in K8s directory binding. Okay. So now it creates a CRD object, and what will happen, you will see here, a new deployment is creating. So it's a second revision of the service. So what I mentioned, we changed the configuration of our Kafka service, and you see that it has successfully started now. We can, for example, switch to the serverless tab in OpenShift. We can easily display there the list of available services on Knative, and you see that all of them are currently deployed. And we can display a YAML. Here, I just wanted to show you that currently a new environment variable has been injected. Okay, here. Okay, so you see that was performed by this Kafka binding object. All right, so let's back for a moment to our presentation. So we are here. We have already deployed payment service. We have already injected address of Kafka cluster to both this consuming order events application. We can switch to the implementation of order service, okay? And then deploy order service to the Kubernetes, to the OpenShift cluster. All right, so first, we've got two methods for sending events. We'll start with order publisher here. Okay, so order publisher is continuously generates events. We should set timeout for these events, and we will we'll generate a single event per 10 seconds. Okay, so I will just set 10 here. Okay. All right. Now we need to declare a map method that will generate order. Okay, so I will just generate a simple order that yes, so we will just increase ID each time we generate a new event. I will set random values as a customer ID and product ID fields. It will be a random values beginning from 1 to 10. And okay, so we can do it here. We can just take a look at this constructor to see that we've got a customer product, and we also have amount, product count, and status. So the amount will be, for example, 100. We always choose one product, and the order status is new. Okay, because we are generating a new order. Of course, we need to return this object. We also want to display some information. So order, and we just print this order into the console. So okay, and we also want to save the state of the object. To save the state of the object in repository. So repository persist order. Okay, and well, just because we've got a method that continuously generates events, I just want to perform user transaction here. Of course, I need to, catch exception in case of any problems. I will just very simple implementation here, not connection, but I just need to begin transaction here. Okay, and we'll just commit it. So each time we'll send a new event will commit transaction, because in different behavior it won't be commit. It will be commit when our generator would finish generating events. Okay, so we need to use an outgoing annotation, and we also need to define the name of a topic. And in this way, it will be order events. Okay, because we are sending these messages to the order event. Okay, show what happened here. Okay, so that's all with this implementation, and we also have a method for handling responses from both payment and stock service. So we also need to annotate it with func annotation. It means that this function will be exposed as an HTTP endpoint, and now we just do a confirmation. It's not very complicated implementation. So if we receive a rejected order from one of the service, we need to roll back this transaction, so send back an order with rollback. If we receive confirmation from both applications, we are just confirming the state of this transaction. Okay, so we can also back to the order sender, because we are using order sender to send orders. So we need to also define channel as before, and it will be order events channel. Okay, so we also need to provide some configuration properties, the same as before. I'll just copy this configuration from the previous service and insert it here. So you see that we've got reserve order events, so we need to change this to order events. So let's just do it everywhere here. Okay, single one. And the other properties are the same as for the previous application. We just need to add a single property here. It's merge. Why? Because we've got, in fact, two sources of events, if you think about it, because we have a generator. It sends new events, and then we've got a function that confirms events. So it's the same thing, in fact. Okay, so now we just need to do the same thing as before. So we need to deploy our application to the Knative. Okay, so let's switch to the order service and I just perform Maven Build. Okay, Maven clean. Okay, so while we are performing a build, so the same as before, our application will be deployed on Knative. And of course, the same as before, we then need to set the address of our service. So we'll create the Kafka binding object. Okay, so let's switch back to the presentation for one moment. So we are here. If we will create the Kafka binding, we'll be able to send generated events, the generated orders to the Kafka topic, but now we need to transport these orders from a topic to the Knative broker. And that's why we need to define a Kafka source object. It's another CRD provided by Knative Eventing, which is used for getting messages from topics and sending them to the target sync. In this way, in this case, we will our target is broker. Okay, so we've got the topics, order events, and reserve events, and we also have a broker called default. Okay, so our application has been deployed. So now let's apply first our Kafka binding object, same as for other applications. Okay, order service binding. Yeah. All right. So now it creates a second revision of our service, same as before, and it should be restarted. So we can just, for example, verify binding objects here on OpenShift. If they work successfully, you can and see here, okay, all of them are ready, as you see. We can also switch to OpenShift console. You see that all applications has been deployed on Knative. Okay, so now we just apply the Kafka source configuration. So this object is responsible just for getting messages and sending them to the broker. Okay, so also apply stuff source. Okay, so it has been created. After creating this object, you will see that a single pod will be running here. So this pod is responsible for just for getting these messages from the topic. It's a single pod dedicated per Kafka source. So we are just interested in running services. We've got some pods in the crash looping state because we have these are these pods for the revisions that doesn't have Kafka address injected. Okay, so currently we have only a single application running because we are using a scale to 0 feature. So it means that that if there is no any incoming resource to the applications, they are just scaled down. Okay, so what next? Okay, so this messages has been already sent to the broker, and now we need to define triggers. Okay, so triggers are responsible for getting images from the broker and sending them to the target services. In our case, so we've got 2 triggers here. We have a trigger for example, payment service. So you see that we are defining here a broker. So it is a default broker. We've got the filters here. So it is a following the combination of cloud event, because here we have a namespace. Here we have a name of our Kafka source, what is Kafka source to broker, and here we've got the name of our topic. Okay, so we can go to the payment service and also apply myself. Okay, it is trigger. Okay, we can do the same thing for stock service. Okay, so I'll just go to stock service and do the same thing here. Okay, so I will apply second trigger now. So we are here. We can take a look at a list of event sources, brokers, triggers. We see that all of them are ready. And now we can switch to the last part of our application. So while the payment service and stock service will receive events, they are able to send them to the Kafka topic, and now we need to send back a response to the order service. So we need to create another trigger that's responsible for filtering events sent to the reserved events topic. So let's just do it here. So switch to the order service and just also apply another trigger. Okay, now we can, for example, switch to the developer perspective, and you see that we've got some kind of a topology view here, and see all the applications. So we have Kafka broker defined here. We've got triggers here that are responsible for delivering these messages to the subscriber, but there's still no any messages. So okay, we just change implementation, and we just disable scale to 0 features for order service. So let's just wait here. Sorry. Okay. Just copy it here. So you see that we can place it here. So now we will activate our order service. Let's save it. And what we can observe now is that, okay, our order service is starting. As you see, both payment and stock service are starting too. And what is going to happen, because now we have a communication between them, so we can just switch to the logs, and we can, for example, download it to see what will happen here. Okay, so you see in the logs that, for example, we send an order, we receive some kind of responses on this order from applications, and the order state has been updated to stock service. Okay, so let's just and also, for example, list the structure of cloud event here. So you exactly see what is the structure of the event that is coming to our application. Okay, so you see that it adds some headers here, and for example, this is the header we are filtering out by the trigger, so it is famous order service. Okay, so that's probably all what I wanted to show you, because we're coming to the end of the time we have for today. So you didn't have any questions during the presentation, but maybe you can ask them now. But of course, you can also contact with me. I don't know, for example, on Twitter, on the email, if you have any other questions. And on chat, you also have information from JCon organizers, so it's worth to read it, I think. Okay, so if you don't have any questions, I think I'm not sure if this presentation will be sent, but you can contact me offline, or I can also share, for example, a repository with this code. In fact, it's available on my GitHub account, so so I think we'll be able to find it. Okay, so thanks. Thank you for attending my presentation. I hope you are enjoying it. And well, I hope it was a good introduction to serverless, to the Knative eventing on OpenShift. And I hope you will do something with it in the future, because it's very promising technology, very interesting, like serverless. So thanks again. And bye.